Exploring Hobbies, Astronomy.
Hi, and welcome to Exploring Hobbies. I'm Jamie Fouché, and today we've got Stephen Whitty with us, and we're going to be talking about astronomy. Thank you so much for joining us today.
Well, it's great to be here.
Great. Tell us how you got started in astronomy.
Well, technically, I really don't remember when I wasn't doing it. So the family had one of these cheap refractor telescopes. It was about the diameter of this finder scope. It set up on a tabletop. It had a tabletop tripod. The tripod was sturdy. The scope was usable. I think it was maybe 20 power. And I saw things like the rings of Saturn with it, and things that I happened to be able to find. I remember going into the backyard. We had a picnic table. It was a very wide open backyard. There weren't very many trees in it, and you could just point the scope almost anywhere. It wasn't very good for looking straight up, but it got me along. So when I was in elementary school, I think, there was you would call it a day camp, except that it was at night. There was an astronomy camp.
It was a night camp.
That's right. And I would go out there at maybe 7. It was still light. It was in the summer. And there would be a lecture for about an hour, and then they had telescopes outside, and we would look through different things. And I remember really vividly, they had a really decent observatory, and they showed Saturn through that, and that was spectacular. That was extremely good. Since it's online now, since the observatory is online, I've gone back to see if I could figure out how big the telescope was. And they've replaced it. They've replaced it with a different style telescope. I know It's completely different, so I have no idea.
So it's not the same as when you were a kid.
It's not the same, no.
So it sounds like in your household this might have been kind of a family interest. Is that common? How do most people usually get into astronomy?
I don't know. I think the easy way to do it is to happen to hear about it, hear about a star party, and. And so in the greater Michigan area, in the southeast Michigan area, the big star party is Astronomy at the Beach. And this year it is September 27th and 28th. That's a Friday and Saturday toward the end of September. Okay. And if it rains, like last year, we had a thunderstorm, we get 3,500 people to show up over the 2-day period. But in 2003, we had 13,500 people show up to see Mars closer than it had ever been, right? And we had gorgeous weather and all of that other stuff. But even if it rains, these people will have a good time because there's a big tent, there are speakers. We had an astronaut last year. It's a good time. So there are things to do. There are booths with things to do. We even have a blow-up planetarium. It's pretty cool.
That sounds great. How do you go about buying a telescope? I assume that's one of the first things you need if you want to see more than what you see with your naked eye.
Yeah, and the advice is, before you buy a telescope, visit an astronomy club. So back in 2000, I had $1,000 to spend. It was burning a hole in my pocket, and I had to spend it. So I looked up online, and we had the internet back then, right? Mm-hmm. And I settled on a telescope, and it was almost. I was going to spend almost every nickel I had, and before actually making the plunge, I called up a friend of mine who I knew was into astronomy, and he was living in New York. And I asked him what he thought of the idea, and he said, "Did you know that I used to have an 18-inch telescope? This is a 10-inch, so this is like twice the diameter, and this thing was twice as tall as that he had. I mean, it was a monster, and it's really quite expensive." And I said, "No, I never saw it. What happened to it?" And he says, "Well, I sold it." And I said, "Well, why is that?" He says, "Well, because it takes 3 people to set it up, and my wife could help me, but then I would have to scrounge around for somebody else to help set it up." And I thought, why is he telling me this? And it turns out, so he says, go to a club, and I went to, it turns out to be the Warren Astronomical Society, and they have an observatory on 29 Mile at Wilcott Mill, And I went to one of their open houses in February, so it was freezing cold out. In fact, it was also cloudy out, but there was a guy there, in fact, Marty, who showed me and some other people who had shown up the instruments and stuff at the observatory. We couldn't see anything, but we saw the stuff. And he got to a 10-inch telescope. Now, this is a 10-inch, but he got to a 10-inch telescope that had been club built. And the one that I had ordered, the one that I was thinking about ordering, was a 13-inch telescope. And I looked at this 10-inch telescope and I said, that won't fit in my car. And I just put my plans on hold.
Yeah.
And in fact, I didn't buy this telescope until 2005. So there are three things that you need to consider. And the portability, which is, they all begin with P, right? So there's price, you have to be able to write the check. And then there's performance, which I'll get to, and then there's portability. And if you can't pick the thing up, if you can't assemble it, if you can't get it in your car or wherever it's supposed to go, then that's a constraint. You know, just don't do it, right? Because if I had bought this 13-inch, it would still be in my garage or in, you know, wherever, but I wouldn't be using it a whole lot, maybe just in the yard. This scope turns out to be, it's got a 1,200 millimeter focal length, but it turns out that means that this tube is 4 feet. It fits across the back seat of any car I've ever seen. You just open open it up, put it in the back seat, and strap it down with a seatbelt.
So mobility sounds like is kind of a key piece in order to really get the most use out of that kind of investment. It needs to be something you can take with you to different places to use for viewing.
Yeah.
So it sounds like the clubs can be a really good resource in terms of looking at equipment and understanding, you know, what you're investing in and how to use it.
Yeah.
You know, what other kind of activities can people expect if they joined a club or started participating with an astronomy club?
So the Warren Club, I belong to two clubs. I belong to the Warren Club and the Ford Amateur Astronomy Club.
Okay.
The Warren Club has 2 meetings a month, and so there's a first-rate talk at each of these meetings, 45-minute to an hour talk. And sometimes there's also an additional 10 or 15-minute talk. There are a bunch of activities that go on. The club has the open house every month. They have an open house. The Ford Club most of the year has a beginner's night where out at Island Lake they or Lake Erie Metro Park, and they have basically the public is invited, and you can bring a telescope if you want, but you can just show up. Somebody will show you something in their scope. It doesn't ever get easier than this. Somebody shows you something that they found in the sky. It's really cool, and you get to use their scope, and it's free, and like. It doesn't get easier or cheaper than that.
You just have to be present and have an interest, and that's it.
You don't even have to have an interest. If you look, this is what I like. I've shown Cub Scouts or adults, and adults especially. I'll show them Saturn. Saturn happens to be up right now. We're going to lose it in a couple months, but I'll show them Saturn, and they'll look through the eyepiece, and then they'll like look back, and they'll like look through the opening, and they'll say, "You've got a picture of it somewhere in there, don't you?" No, it really is Saturn.
Yeah, that's great.
That's what it looks like. So you get to look at something cool, and you get to be amazed. And even if you were doubtful beforehand, you can be changed.
One look, that's all it takes.
To the dark side.
Okay, then. Be assimilated.
That's right.
So are there different types of clubs in terms of like age group? Like are there clubs that are just for kids, clubs just for adults, that sort of thing? Or in general, are there just kind of clubs and you're going to find a mix of everything?
So the Ford Club refurbished, they did a project where they refurbished a high school observatory in Lincoln Park. And they've got a scope bigger than this, and it's on a mount so that you can do astrophotography. They have enormous amounts of capabilities there. They had gotten a grant to pull this off. But the agreement with the school is that they run it, and they can use it for public outreach. They can use it for themselves. They will actually use it and show the kids stuff during the day or in evenings. They actually have it open most clear nights at the Lincoln Park High School, the Hector J. Robinson Observatory. This observatory basically lets you go there almost any time.
Okay.
So and because the club has over 100 people in it, there's a really decent chance that someone will know how to operate this scope forever, right? Because you only need like 3 or 4 people who have an interest in running the scope, and then it'll be open. Whereas the observatory was originally built in the early 60s by Hector J. Robinson and some students. And when the teacher retired, they basically shut down the observatory until somebody else had the interest. Now that there's a club with 100 people, you're always going to have somebody who wants to do it, and it should be open forever now.
Great. So it sounds like in terms of club makeup then, as long as there's some people there who understand how to work the equipment, the rest of it is just anyone who's interested in taking the time to come out. And
right. But now that the observatory has opened, there's now a student club. So there is in fact a club of just high school age kids who come out and they use it, and they do other things as well.
Great.
So,
you mentioned Saturn specifically, and that's something that's maybe only good for optimal viewing for a little bit longer. What are some of the more interesting things that you haven't had an opportunity to observe?
So there are maybe 5 or 6 categories of things.
Okay.
So there are the planets. There's the moon, and you can call that a planet. I would, but in fact, if you're a scientist who studies the moon, you're called a planetary scientist. So it must be a planet, right? So the moon has tons of detail. It has lots of things to look at. I know of maybe 3 of them, but that's just me. It's on my to-do list to study the moon a little bit more. We have Mercury and Venus. We had a Venus transit last year. The next one is in 2117 or something. Watch for it.
And what is the transit?
So this is Venus went in front of the sun from the perspective of the Earth. So I had my solar filter on my scope, and I let people look through the eyepiece. I had a solar filter on my finder scope, and I kept the scope pointed at the sun for about 3 hours last year. Nice. So, but anyway, Venus itself, you can actually see phases just like the moon, so that's pretty cool. Mars, from time to time, is big in the sky. Big in the sky is really quite small compared to the moon. It's at best it gets to be 1/75th the size of the moon, right? So the visible size.
Yeah.
It's actually twice as big, but it's a lot farther away. So Jupiter is always great, almost always great, unless it's behind the sun. Jupiter, at the moment, it rises at like 2 in the morning. It becomes good at about 4 in the morning. It's great just before sunrise at the moment, but as time goes on, it'll rise earlier and earlier until basically we lose it to to the sun eventually. So as the Earth goes around the sun, that happens. Jupiter has these 4 moons. It has these bands of clouds, and you can see stuff going on, not in real time, but you can see stuff from day to day going on.
Wow.
And there's always something different to see on Jupiter. Saturn, with its rings, is always gorgeous. It has half a dozen moons that you can see through a scope like this. The rings are always an eye-catching thing. It's colorful, etc. The planet itself is fairly bland. It's sort of yellow. You can see a little bit of activity, a little bit of banding every now and again, a big storm, but it's fairly rare. Uranus and Neptune. Uranus is just barely visible naked eye. I've seen it a couple times. With a telescope, it's a little disk. It's a little blue disk. It's not very big, and you never see any detail on it. Neptune, in a scope like this, there is a moon, Triton, which you can see if it's in the right place and you've got all your ducks lined up. Neptune is not visible without a telescope. You really need a scope to see it, and you need a good finder chart to make that happen.
Okay. And so those are all, I mean, those are the planets,
so those are the planets
in our solar system.
That's right.
What about things like time-based events, like certain, I don't know, meteor showers or comets or something that maybe you can't see all the time? Have you?
Sure.
Have you
Well,
had an
actually,
opportunity for those?
you can actually see meteors. Maybe there are periodic meteor showers all year round, but you can almost see meteors any night. You know, any clear night, you can go out, and if you wait long enough, one will zip by. Not necessarily from anywhere in particular, but almost any night. So in a scope like this, you can certainly see stars. You can see double stars, or there are stars that have more than just two. They'll have 3, 4. I think Castor has 6 stars that are known. There are small clusters of stars. Stars tend to form in a large gas cloud, and so they form not just one single star. They form like a family of stars. So the sun would have formed that way, but it's been so long, 4.5 billion years, that we don't know of any stars that would have been in our cluster. We have some candidates, but we have nothing remotely like proof. The sun will have gone around the galaxy about 22 or 23 times since the beginning, and everything has sort of gone its own way. But then there are things called globular clusters, and these things have held together for a very long time, some of the oldest objects in the universe. There are globular clusters that are 13 billion years old. They're the age of the galaxy, easily. There are nebula, so you might have a star explode and the gas gets spread out over a large area, or you might just have a cloud of gas that is in the process of forming stars. So M1, the Crab Nebula, is the remnant of an exploded star, and M42 is the Great Orion Nebula. So that'll be coming up in the fall. I mean, right now you can just wait up later at night and you can see it. Orion rises. So there's a 3-star belt.
Orion's belt. One of the few that I can find with my naked eye.
That's right. And then there's a 3-star sword that sort of hangs from the belt, and the middle star, if you will, is in fact the nebula. It's quite bright. Even a relatively small scope, you can actually see the nebulosity in relatively dark skies. So just the finder scope here, aniscope, binoculars, will show you something. I first saw it in a 4-inch telescope, so this is 10, so this is less than half the size, and you could see quite a bit of detail, and I was very surprised. I thought you'd need something more than that.
Bigger than that to see. Are there one or two things that were just, really took your breath away, that are really, that really stand out to you in terms of memory of it was a great thing that you had an opportunity to see? Almost
anything that I've gotten to see for the first time really is like that. So just last week there was what they call a classical nova in the constellation Delphinus.
Okay.
So that's the dolphin.
Yep.
It's not a very bright constellation. In fact, it is the second dimmest of the 88. I can find it because there's a patch of sky more or less in the south, kind of low in the south this time of year in the summer. And I can't see any stars whatsoever. I've got so much light pollution, I can't see any stars there at all. So that's where Delphinus is. That's how I know to go there. But actually, with my telescope, I have a computer, and the computer helps you find things. So what you do is you tell the computer, okay, so here is the bright star Arcturus, that's one that I commonly use this time of year, and Vega, another extremely bright star, and I tell the computer, okay, I'm pointing at this star, and I tell the computer, this is it, and then I point to the other one, this is the other one, and then it says, okay, so what would you like to see? And so I told it, I wanted to see this planetary nebula in Delphinus. I gave it the NGC number, and it turns out that this nova was within a field of view of this nebula. Now the nebula itself is too faint for even this scope to look at. So So this telescope, so I punched in the numbers and it says, okay, go left 30 degrees and up 12 degrees maybe. And as I move the scope, it changes the numbers. And when it gets to 0, 0, I look in the eyepiece. And it's pretty easy, right?
Yeah.
And you can move the scope pretty much as fast as you want, as long as you don't move the base off of the ground, right? As long as it's still on the ground, you can move it pretty fast and then you're looking. And I looked and I went, I can see an awful lot of things. And I spent another hour and a half figuring out which dot, because it looked like a star, which dot is the nova. Now, classical nova is you have a white dwarf that's in a binary with another star.
Okay.
And they're very close together, and the white dwarf steals gas from the companion star. And over time, and it can be decades, or in this case, probably hundreds of years, because we haven't seen this one before, it builds up a layer of hydrogen, mostly hydrogen, on the surface. And the white dwarf itself is very hot, much hotter than our own sun. This is really the core of a star like our sun. And what happens is, so you've got the heat. Well, as you get more and more pressure, you can think of this hydrogen like an ocean, right? And the pressure at the bottom is very high.
Okay.
Well, you can get the pressure high enough so that you get nuclear fusion. And the whole star sort of rips apart as a big hydrogen bomb, really big hydrogen bomb. And the star goes from, you can't see it at all in this case, even with professional telescopes, even with really big ones, to, you can see it with your naked eye if you're in dark skies.
Bright.
Because and this one in Delphinus should be visible for, we think, for maybe 150 or 200 days, so for most of a year. So, you get to astronomy at the beach in September, and you might be able to find somebody who would show it to you.
Who can point it out. That's great. You have brought some equipment with you, and so you started to tell us a little bit about how this computer works. Can you demonstrate for me a little bit of some of what you brought and show us how this works?
Sure. I think we'll start with the scope.
Okay.
All right. So the scope has, I mentioned the solar filter, and the solar filter is this thing on the top, and it comes off, if you're not looking at the sun. And what the solar filter does is the sun is really bright, and this one lets through 1 photon per every 100,000, so not very many. And that's so that when the light comes out of your eyeball, it doesn't burn your eyeball out.
Which is a good thing.
Without the solar filter, if you take a piece of paper to the eyepiece, if you point the scope at the sun and you take a piece of paper to the eyepiece, it catches fire right away. Right away. There's no delay.
Wow.
It's
Okay.
like, ooh,
Yeah.
don't do that.
Don't do that.
So,
Definitely.
safety with the sun is important. I have a solar filter for my finder scope, but before I had that, I would simply not bring the finder scope out during the day because there's a temptation to look through it, and that would be bad no matter what.
Okay.
So
You've mentioned the finder scope a few times. I am assuming it's something that you use to kind of get a ballpark of what you're looking at, but explain for those of us real novices, explain to me just a little bit about what that is and how you use it in comparison with the rest of the telescope.
So the main scope is large because things are dim at night, and so you want to get a lot of light collected, and so that when you're looking through the eyepiece, you can actually see it. And there's about 1,500 times more light through the scope, through the eyepiece, than your naked eye. Your eye is maybe 6 millimeters in diameter when it dilates as big as it gets, and this is 250 millimeters in diameter, and then you can just do the math.
Yep.
So this isn't as big, but the magnification is low. This is a 9-power magnification finder scope, and so the field of view is quite a bit bigger. So this is actually similar in field of view to a pair of binoculars. And I also use binoculars. I often use these to scan the skies quickly to find things. You actually have to sort of lean over with this one. You have to lean over and have your head sticking up. It's not terribly convenient. So sometimes I'll use binoculars. You look through this end. These are the 21. This is 8 by 21. So these are the 21 millimeter oculars on this side. They're quite light. They're 100 grams. That's 3.5 ounces. And they're small enough that I can fit them, especially in the winter. I've got a coat pocket. I can just leave them in there all the time, and then I always have them.
With you.
So I use these a lot, but I don't really look so much with the objects with them. Sometimes I do. I've looked at an eclipse of the a lunar eclipse. That's where the shadow of the Earth is going over the moon, and I'll use binoculars because I can see the whole thing. Well, actually, I can see the whole thing in this scope. So even in the main scope, I can see either the whole sun or the whole moon in the scope. And then I have different eyepieces, and I can put in a higher magnification eyepiece for looking at detail, maybe just one crater on the moon, or there's a feature called the wall, which the sun, it really is a wall, and the sun comes from one side at a particular time of month, and it leaves a shadow, and what you're seeing is really the shadow going up. But when you look at it through the telescope, it looks like a cliff.
Like a big cliff.
It really is,
Wow.
and it's long. It's it's like 100 miles long.
Yeah.
So the finder scope is really important. It has the field of view. You can actually find the thing that you're looking for, and then you look. It actually has crosshairs so that you know that you're centered on an object, and if you're centered here on the object, then the object will appear in the main scope. I don't know why, but this finder scope comes off easily, and it goes on easily. The thing that confuses me is why it's always aligned with the main scope. There's an adjustment, these two knobs here, but I did that once, and I haven't really had to change it.
Okay.
For some reason. It really works good.
Very good, very good. And so you've brought this other set of binoculars with you.
Yeah. All right. So a lot of astronomers say, "Oh, well, you shouldn't use 8 by 21 binoculars. You should use something that collects more light, because astronomical objects are dim." And they say, "Well, you should use a bigger pair of binoculars." And so this pair of binoculars is 10 by 50.
Okay.
And I picked them up at a sporting goods store that was going out of business. I didn't know that at the time, but they were on sale for $25. And you go, great, $25. But whereas these magnify 8x, 8 times bigger than your naked eye, these magnify 10x. And I find that I can't use them at all without a tripod. Now, I bought them because when I bought them, I already had a tripod for other reasons. And so I thought, well, I'll just use them with the tripod. And I got an adapter, which turns out to be this thing here.
Yeah.
I bolted it to this contraption.
So is that kind of your makeshift tripod then?
Well, this is a makeshift tripod, but
Yeah.
I had these on just a regular tripod. Just a regular tripod that costs 10 times as much as these binoculars. Anyway, I found an article on the Sky and Telescope website under the DIY do-it-yourself section, and they say image stabilize your binoculars, and it took 2 or 3 hours, probably an embarrassingly long time to build this thing, but I built it, and maybe $10 worth of stuff, right? And you use it by putting it over your shoulder, and there's the counterweight in the back, so it doesn't, you can sort of balance it there. And then as you look, you can lean it back. You can actually look quite a ways up to you can actually look straight up, but it's even comfortable up to about 70 degrees to look. And it stabilizes the image because now you've got this big moment arm, they call it in engineering, and it doesn't want to move. It doesn't want to move too much. So it's much more stable than with your hands.
Yeah.
You still have some movement, and you can actually stop that cold by backing up into a pole. So you have a pole. I've got a backstop for I've got a basketball hoop pole, right? And I can just back up into the pole and the image can be absolutely stable.
That is great. Stephen, thank you so much for sharing your wealth of information and for bringing your equipment. It's really been great to actually see some of the stuff that you use. Where can some of the viewers go if they want more information?
Again, the Sky and Telescope magazine website, so you can just look up in Google Sky and Telescope and clubs. And the first Google hit is a finder for, you put in like maybe your zip code, and it'll tell you these are the clubs near you.
Okay,
great. And so clubs are a great resource. And my TV show is a great resource.
And you've got a TV show too,
That's
so
right.
tell everyone the name of your show and how to find it.
Yeah, so it's called Astronomy for Everyone, and it goes out on public access on, I think, maybe 25, maybe 30 towns in the Detroit area. We have a few episodes up on YouTube, and we plan to put all of them up on YouTube eventually, probably fairly soon.
Excellent,
So,
excellent. It has been very fascinating talking with you today. Thank you so much for taking the time to come and share your passion about astronomy. Thank you everyone for joining us today, and please keep an eye out for future episodes of Exploring Hobbies.